Hello everyone. So we'll just start in 2 minutes. So what did we do in the last session? Quick recap. We had done different tests, right, of inferential statistics, right? We had done the different types of tests or hypothesis, right? Starting with z-test, t-test, then ANOVA and chi-square. So today we're going to start with, now we are going to move towards modeling, right? And today we're going to learn three models, three algorithms, association or a priori algorithm, right? Is used primarily by retailers and e-commerce players. Then we are going to learn what is PCA, that is principal component analysis and factor analysis, right? So I'll just wait for 1 more minute and then we're going to start. And we're going to start the session with the sampling techniques. What are the three different types of sampling techniques that are there? So as we had discussed this earlier also, in inferential statistics, we draw samples from the population. We draw random samples from the population, right? We draw random samples of the population, and the samples are such drawn that they should represent the population, right? They should be able to represent each and every, or not each and every, but they should be able to represent maximum characteristics. They should be able to, yeah, maximum features of the population, right? So there are three different types of sampling techniques. Okay, I forgot to ask, am I audible? Yes, loud and clear. Just wanted to be sure so that when I start, there are no confusions at a later end. Okay, fine, right? So thanks for the response, everyone. Okay, so three different sampling techniques. One, the first one is random, right? Okay, so let's see. We have this dummy. You can say it's a dummy data set wherein I have picked up 10 samples and from 10 people and asking them the gender, asking them their gender, right? So this is my data, okay, that I have collected. Sample, sorry, this is my data. Okay, suppose this is or I'll say this is a population, right? And it's a dummy population. Okay, so this is my population. Then this is random, systematic, and stratified. Okay, so first type of sampling is random sampling, wherein I am picking up random samples from the population. So if I have to pick, if I ask all of you to pick random samples from this population, right? So some of you may pick this one, right? 1, 3, and 9. You randomly pick 1, 3, and 9. Okay, and now is this a representative sample? Right? Looks like, because the male and female ratio, if you see, it's more or less the same, but it was a representative sample. I mean, we have picked it up randomly, so it should be a representative sample. Now, sampling techniques can go wrong also if we don't choose the right sampling technique or right sampling methods, right? So they can go wrong also. But yeah, this is a fine. This is one random sample. Now I asked another person, let's say I asked Nisha. Nisha picks up this sample 2, 5, 10, and then Arush picks up sample 3, right? So randomly you have picked up these sample three samples, each having three observations, right? Each having three uh, observations. You have picked up the sample from the population. So this is called random sampling. Okay. Now, what is systematic sampling? In systematic sampling, I follow a pattern. Some pattern I follow. For example, picking every 10th record, or picking every if suppose it's a huge population, I can even pick every 100th record if I have the record of all the population, right? So or it's not just this, I may scientifically think of some other systematic way of picking the population, right? So like here I'm picking every third uh, sample, right? Every third observation, 1, 4, 7, 3, 6, 9. It could be I can pick up every fifth also, right? So another I could think of is 5, 10, and okay, not fifth. In this case, I'll take fourth, 4, 8, and 2, right? So it could be 4, 8, and 2, every fourth, right? So it will become male, female, and male. So some system I'm applying to pick the observations. This is called systematic sampling. Clear? Random and systematic is clear to all of you? Okay. If this is clear, I'll move to third type of sampling called stratified sampling. In stratified sampling, I first look for the groups that are there in the population, some relevant groups. For example, here I have the groups for gender, right? Male and female. Then I see what is the ratio of male and female, right? And then I pick the samples maintaining the ratio of male and female. Okay. So I picked up this sample. Let's say this time I picked up a sample of five observations, and I have maintained the male and female ratio. Okay. So it could be any random 1, 2, 3, 7, 8. It could be 1, 3, 5, 9, 8, 9, 10, or any other, right? So this is called stratified sampling. For example, when is stratified? In fact, most of the time, because the surveys we do, they do not cater to only a specific segment. Like most of, if I have to launch a product, right? Uh, I will see it's how that product is received by different age groups. Let's say I launch some innovative watch, right? Some new watch I'm planning to launch, and I want to see how that watch is perceived by that the features of that watch is perceived by different age groups, right? So I am here not going to take random samples. I am going to first get the proportion of the population between and let's say that product was the audience for the product is 20 and above, right? So I'm going to uh, I'm going to first get the ratio of the population between 20 to 30, 30 to 40, 40 to 50, 50 to 60, and 60 to 70, let's say, right? So I'll get that ratio, and then I'm going to pick the sample maintaining that ratio, right? Is that clear? When I maintain the ratio of the relevant groups of my interest, that is called stratified sampling. Is that clear? the three sampling techniques: random, systematic, and stratified. Right now, when you pick the sample, right, and what will you do? What you do with the sample? You create a model, right? Why do I pick a sample? Either I have to maybe um, estimate the first. I'll analyze and then estimate the. I will have to using a model. I would want to estimate the dependent variable. Okay. Can you explain stratified sampling? Sure, Bharat. Okay, stratified sampling. Let's first read about this, right? Stratified sampling maintain the proportion of the subgroups of the interest. Maintain the subgroups of, yeah, interest. Okay. Bharat, can you tell me this is my population, right? Small population I'm interested in, right? Bharat, can you respond? Because so that I know you're there and you're listening, right? Can you tell me what is the ratio of males and females? 3 is to 2. 3 is to 2 is the ratio. 6 is to 4. Yeah. Right? So, when I'm going to pick a stratified sampling, I am going to be random. I'm going to pick it randomly. But in that random sample, I will maintain the ratio of male to female so that the broader proportion of the variable of interest is maintained. 3 is to 2. Can you see? Let me take another, let me pick another sample, create um, 415, sorry, 415, and then 9 and 10. Can you see that ratio is maintained? Here, if you notice here, the ratio is not maintained, so I may end up, it could be, if it depends, if my the product I'm launching or the activity I'm doing where gender is an important variable, then this sample may go haywire. This sample may not give me this sample may not represent a correct population. But if the experiment I'm doing or if the activity I'm doing, right, where their gender is not of importance, right, then this may be a correct sample. Are you getting it? But if gender is a very important variable for me, right, then of course I will prefer a stratified sampling so that I am capturing males and females in the same ratio as they are in the original population. Is that clear, Bharat? Now is it clear? Okay, fine. So once you have collected the sample, you run models on the sample, and it is not that you just start running a model to predict some dependent variable, right? And dependent variable uh, can be categorical or it can be even continuous, right? Right. So when we have a continuous dependent variable, we have different algorithms to or models to deal with the data, and when we have categorical variable, we have different models to deal with the data. Okay. But before we are going to see dependent and independent variable, right? Before that, when I have collected a sample, the a very important thing we do is I don't put that entire sample in the model, right? I don't just I've taken the sample and I just use that entire sample to build the model, right? So we do a technique. We split the sample into test and train, right? Or right, we split the sample that we have collected into test and train, and this technique is called cross validation, right? We do cross validation, and what is cross validation? The test train split, right? We split, and what is the ratio and how do we split that? I'll discuss, right? The test train split is the technique of evaluating the performance of a machine learning algorithm. Means when I collect a sample, see, let's see, my population was of 1 million, right? I'm doing a test and on which I'm collecting a sample for which I'm going to build a model, right? So I collect a sample for 1,000. Out of this population, I collect a sample of 1,000 and then I split that sample into test and train. And on this train data set, now my sample is divided into two parts, test and train. Again, this is done randomly, right? This division is done randomly so that the um benefits of that randomness is not lost, and even the train and test represent my population effectively, right? Or they are good representations of my population. Okay. On this train data set, I build the model, and then when the model is built, see, it's not that when you have collected the samples from a historical data, right, and you build the model, right, you would not want to deploy the model immediately on the live data wherein you make mistakes, wherein your model make mistakes, and then you um, correct it and we lose some business because we are running a wrong model. Okay, are you getting this, right? I am not going to deploy the model immediately on the live data, right? Because here my risk is going to be high. So that is why this is done. This is done so that before deploying the model, I am able to test the model that I have created on some dummy or on some historical data and check how accurate the results of my model are. Are you getting this? Right? That is why we do this cross validation. Okay, let's go through it further. It can be used to classify, or I'm here, right? It can be used for classification and regression problems and can be used for any supervised learning algorithm. Now, another term coming up, supervised learning algorithm. We are going to discuss this, right? Supervised and unsupervised. Okay. The procedure involves taking a data and dividing it into two subsets. The first subset is called training data and it is used to fit the model and is referred, to fit the model or to build the model. Okay, to fit the model or build the model. Okay, the second subset is not used to train the model. Training, when we say training, means we build the model on it, right? This on that second subset, we don't build the model. Instead, the input element of the data set is provided to the model, right? In fact, we test the model that we have created on this test data, second subset. And then predictions are made and compared to the expected values. This second data set is called test data set. Now, when I run the model on test data, when I um, yeah created the, and when after creation, when I run the model on test data, right, it's going to give me some results of the dependent variable, right? Right? For let's say my equation was y is equal to some very simple equation I'm taking 3x plus, okay, let's 3x whole square, 3x square, right, plus 40x plus 10. Just randomly, I've just put it randomly, okay. Let's say, so here which is my dependent variable? Y, right? And which is the independent variable? Of course x, right? Now, sometimes you always remember this dependent variable. Let me put it here also, because y and x. Y is the dependent, x is independent. Dependent variable is also called predictor variable. Sorry, the outcome variable, and also the predictor variable also, right? I think it's all the predictor variable, uh, outcome variable, and this is of course the input variable. Dependent is also called the predicted. I think it should be the predicted variable, and the predictor variable is x. I'm forgetting the names. Yeah, predictor and predicted, and there are one more name. I'll just get it right. I'm just slipping it, right? So dependent, independent, right? Outcome, input, predicted, and predictor. Okay. So these are the names further given to dependent and independent variable. Okay. Uh, and now coming to training data set. Yeah. So training data set, once we have, okay, now this split, another thing, this split between training and test, right? We do it randomly, but what should be the split? It could be 80-20, it could be 70-30 also, right? And it could be 75% or even 25% also. But see, it depends. If you think you have a good enough sample, right? You have a decent enough sample that is big enough to represent the population, right? You're going to, you can have a bigger pie in the training data set. But if you think your sample is not big enough, right? I would want to have more features captured in the training data set, right? Do you agree? Because the model on which, sorry, the data set on which my model is going to be built, right? I would want more maximum features to be captured in the in that. So I would keep this percentage higher, right? If I have a smaller, if I have just right sample, or I think the sample is size is smaller. But if my sample size is good enough, it's big enough, I can keep this ratio lower. And this is very arbitrary. This ratio, there is no scientific technique to get this ratio. You can, depending on how much observations you have and how much you think your sample is representing the population, right? You fix this ratio. Is that clear? Yeah, yeah, Nutan, you're right. Label and it, it is also called label and feature. Okay, fine. Yeah, it is also called label and feature. And there is another name. I'm just missing that name. Yeah, I think predictor response variable. One is called response, and yeah, I'm again slipping that. This is the response variable. I have the name when we do regression tomorrow, right? The other one is called, anyways, right? Okay. So till here things are clear. Training test data. Why do we do it? Can you explain what does that formula means and use for? Which formula? I have not used any formula here. Are you talking of this? It's a random. It's a random equation I have written, right? It's just an example I have written to just let you know what are dependent and independent variables. Okay. Okay. Now, now, okay. If suppose with the model I came up some values of x. Okay. Let me actual. Okay, I'll take this in the regression. Leave it, right? So till here it is okay, right? Objective of doing cross validation is to estimate the performance of machine learning model on the new data. Now, as I said, when the model is created on training data, right? Do you think I should be testing it on the training data only? When a model is created on a training data, on some data, to check the robustness of the model, I should be testing it on some new data, right? And that too, I would not want to test it on the live data because there the risk increases, right? So, to just because of these two reasons, that one, if I test it on live data, the risk is I will be able to check the robustness, but if there are some alterations to be done, then I am I have lost the business, right? I made some wrong decisions there, right? Also, I would not want to test the model on the data that I have created it. The robustness of the model will be checked only when some new data comes in, right? Okay, it is because of these reasons we divide this into test and train. Okay, now, okay, this is how we expect to use the model in practice. Fine. Now, namely, to fit it on an available data with known inputs and outputs, then make predictions on new samples. Okay, what is, yeah. Uh, I, test and train, yeah. I think I've inserted this later, these two sentences. So it is after this test and train, namely, we divide it into test and train, namely to fit on the available data with known inputs and outputs. So I have created test and train from the known sample that I've picked, right? So I would want to test it there and then make predictions on new examples in future where we do not have the expected output. Now tell me, now see what happens. I'll just take a banking example to make you understand this. Suppose I have customer ID, right? And for this customer ID, I uh, take some variables. This is Y, and my Y is uh, fit to loan. Means, is this customer fit to be given loan or not, right? And X, there are some X variables, right? X2, X3. I'm just taking three variables, right? So I'll take just, I'm building this, so just I'll take 2 3 minutes. 10. Let's build it for 10. 10 customers. Okay. Yes. Fit to loan. Yes. 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 No. No. And no. Okay. So, okay, let me extend this example further to 20. And I'll just pick this. Okay. So now this is my, let's say, I, this is the sample that I have collected, right? Now, when I collect a sample, right? When I collect a sample on which I have to build the model, I have historical data, right? This is the historical data only. Yes, you cannot collect a futuristic sample, right? Or a live sample. Historical data I collect, and I have some features of the customers X1, X2, X3, and this historically this 20. These were the Y variable, whether I should be giving the loan or not giving the loan, right? So let what I did, I split this into 12, right? This becomes my training data, right? On this I'm going to train the model, right? So this becomes my training data, and this becomes my testing data. Okay, let's put this clear. So this is training data and this is testing data. Notice here I have just taken the ratio 60/40, right? I can take it as 70/30 also, right? That now I have to use my best judgment here. It's not that randomly I'm taking, but yeah, for this example, I'm just cooking up this example, right? Now, test data. Now, when I build the model on training data, my model will give me some results of Y predicted, yes or no, right? It will give, so Y predicted, I have created Y predicted on this model. I will not test Y, the value, the accuracy of the Y on this model. Otherwise, it will give me the best accuracy, right? I will test the accuracy on this data, right? So I am going to test the accuracy on this data. And let's say the model, when I run the model on this data, it gave me yes, no, yes, no, yes, 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 and yes. Right? So this is the result that the model gave me. Okay. So can I come up with the accuracy of the model? Now I have when I have got this when I have predicted the value of y using the model, I have some thing to I have some data to check the accuracy because this is my actual, right? This is my actual and this is my predicted. So I have some accuracy to check, right? So this is let me this is correct, right? This is not correct, then correct, 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 not correct, and correct, correct, right? So two are not correct and eight correct, right? No, sorry, six correct, right? Total eight, sorry, right? So accuracy becomes 75%. Is that clear? That is how you check the accuracy of the model on test data. Clear? Is that clear? How you use validation? How do you do data validation, and then how do you test the accuracy of the model? Right? Explain Z column, sir. For I am Bharat. I am comparing this results from the model. These are the results from the model. I am comparing it with actual test data. I am testing. That is why it's called test data. I am testing it. I am comparing it with this data. Yes, it was yes. I that we could give loan. So my model also predicted that yes, you could give loan. We gave loan, right? And he was a good customer, but my model said you cannot give loan. So is this a correct estimation, Bharat? So that's how this is the result came from my model, and these are the actuals. So I'm just going to compare it and see where my model was correct or not. Is that clear? So accuracy comes out to be 75%. Clear? Okay. Now, yeah, the idea of sufficiently large. Okay, where is it written? Sufficiently large. The test train. Yeah, the test train procedure is appropriate when there is a sufficiently large data set available. Are you getting it? Sufficiently large data set. This I have already discussed. The test train we will do when I am sure that the data I am collecting is sufficiently large to represent the population. The idea of sufficiently large is specific to each predictive modeling problem. It means that there is enough data to split the dataset into test and train dataset, and each of the train and test dataset are suitable representation of the problem domain or the population. Are you getting it? Each I have the problem that I'm trying to solve by creating that model, right? I have test and train both representing that. Clear? This requires the original data set requires that the original data set is also suitably representation of the problem, means of course the total sample, right? Conversely, the test train procedure is not appropriate when data set available is small. Very important. I will not build a test train if I have a sample as small as this. Can you tell me why? Can you tell me why? If suppose I have a sample of this, right? From this population, I will not build, test, and train here. Why? Anyone? Because each is a small sample, it's a small data set. Secondly, each and every element of the sample is a huge contributor to the population features, right? If I remove this one, right, a big chunk of that features it is capturing, it is representing the population can be removed from the model. Are you getting this point? Because each and every, I'm repeating, each and every element is a big, almost, if I say in this, 20% of the population features are captured by each, right? Each element, each sample, each observation in the sample, right? If I remove any one, I am missing out on 20% of the features, and I will miss them out in creating the model. Are you getting this? Right? So the reason is that when the data set is split into test and train, there will not be enough data in training data set of the model to learn effectively. Now, to learn effectively, wait, let me close this. I'm reading this sentence, right? The reason is that when the data set is split into test and train, there will not be enough data in the training data set for the model to learn an effective mapping of input to the output, right? I would not say it's incomplete training data set, but not representative. Incomplete is not the right word, Nisha, right? It is not, it will not be a true representative. It will not be a correct representation of the population, right? See, incomplete anyways, a sample is a incomplete data. I mean, if you use incomplete, that's a wrong word actually here, right? So I'm just correcting you so that you remember the correct word. It's not a correct represent, it will not correctly represent the population, okay? There will also not be enough data in the test set to effectively evaluate the model performance. The estimated performance could be overly optimistic or overly optimistic means it can really impact the performance of the model. If I create a model on a small data set and I miss on some elements, it can effectively go bad, or I mean it can go extremely bad or extremely good, right? Overly optimistic or overly pessimistic, right? Clear? So let's quickly now go to R, and what we are going to do is we are going to do cross validation. We are going to see what are the packages we have to do the cross validation. Okay. Okay. Then there is this concept called set seed, which I'll explain first. Okay. Just I'm just this is the package I've just mentioned. We are not using it right now. Package finder. This package you can install it later. This package helps you install the sorry, this package helps you find the packages, right? Find the right packages or find the packages which are doing. See, there are 18,000. I told you 18,900 packages we have seen, right? It will be very difficult if suppose I want to know which package. Suppose, as I said, I mean after this session, and you've seen also this subject is so dynamic. This tool is so dynamic. Every other day, new things are coming up, and you have to keep learning. You cannot stop your learning when you are learning data science. Okay, every day new packages will be coming. Or some better packages will be coming. Like this R Commander. I never used to teach R Commander last year, right? But you've seen how powerful the package is, though it's not running for some of you, right? But you've seen how powerful the package is. It completely, I would say, it's completely code free. All you have to do is just an interface. Very powerful package. Then there are some more packages which I have recently discovered. I will share those packages. In fact, I would want to cover those packages in the last session, but right, some very interesting packages. So you, as you connect to the community, you will keep on learning. You will keep on seeing new packages coming and which are far more powerful than the previous packages, right? So this package finder package comes really handy. It really helps you in finding the packages required for a particular task that you have to do, right? So if I run library package finder, I will, in the add-ins, you'll see package finder. Once you run this, you'll see in the add-ins, you'll have package finder. If I click on package finder, I will open a window. Herein I can search. Suppose I want to check the packages that are doing regression. That can do, or okay, let's not do uh, clustering, right? Clustering. So I can just search and it will give me the list of packages while we are on search, right? Package, find package, clustering. There is, okay, this is my task. This is my search, right? 604 packages found. Now it will also list the packages based on the uh, relevance. It's not that it's going to randomly list the package. See the score, right? So it's going to list the package based on the score, right? So that's clustering, right? So it will this package can really come handy. Okay. Okay. Next, I've already told you to, if you want to empty the global environment, rm list equal to ls. You do this, the global environment, all the variables will be gone. Okay. Now coming to set seed. What is set seed? Okay. I'll again take you to this sample, this example. Suppose I have to build the model, right? And I ask you to pick a sample from this, and you come up and pick this sample. One of you come up and pick this sample, right? And create a model, right? I ask you, uh, I ask the other person, maybe the second person, to again pick a sample. You again, some other person came. Okay, earlier it was Nisha, then Vaibhav came, right? And picked this and created a model, right? Do you think the model that is created on this and the model that is created on this will be exactly the same? No, right? There are going to be some little variations. Some variations will be there, though. My aim is to see whether the model is correctly able to predict my predictor, that y variable, dependent variable, right? But there are going to be some, that model will not be exactly the same because it is built on some different model. And suppose another situation, today you build the model on this, right? Right? And you deploy this model, and tomorrow you want to come and check the model. You want to test the model, right? Now every time you every time you pick a sample, random sample, it might, if you ask R to pick a random sample, it will pick a different sample, random sample, right? This is a random sample, this is a random sample, this is a random sample, right? So it will pick a different random sample every time, isn't it? If you are running this model today and after 2 months you want to again improve that model, right? First you will check how my earlier, what did I do, right? And you run the code. It will pick a random sample. It will not pick that same sample, right? Agreed, right? But if I want to test, I am I have built the model today, and tomorrow I am just checking that model to improve that model. I would want to see what was the data on which my model was built, right? I would want to test it on that same data on which it was built, right? So I would want definitely a random sample should come, but I would want to fix that randomness, right? So that anytime in future I want to come back and check that randomness is there, but I am fixing that randomness. Okay, it's like something like stratified, wherein I fix a system, right? Or you can say it's a kind of a systematic sampling, wherein I just fix a pattern of picking a random sample, right? So I can set that randomness with the help of set seed, right? I pass a command before we do before I do cross validation. I pass a command set seed with a random number, right? So it will set the randomness of the data you selected, keep the randomness constant. Okay. Now every time you come and run the model with a set seed, oh sorry, every time you come and pick a model or pick a data, pick a sample from the population, right? It will pick this same sample, though it's a random sample, but it will pick the same sample, right? We'll see this, right? First time it selects the data randomly. So first time, of course, when I run set seed, right? First time it will pick the sample randomly, but when I come to it next time, it will pick that same. It will maintain. It will keep that randomness constant. Okay. To select the same samples each time we run the code. Yes, right. You're right, Nutan. We run this set seed to select the same sample, but it's a random sample. First time it was selected randomly, right? But next time if I have to check my model on which it is, like a teacher says, I will take your surprise test. Right, right, right. 80-20 can provide different results for you and me. Exactly. Yes, Suman, you are right. Right? Okay, right? So cross validation, I've already explained, so I will just pass this. A lot of time I spent on this, right? Okay, so coming to, let's see which packages can help me do cross validation. I want you to install this package line number 38 quickly, everyone. Install package CA tools. T is capital, mind it. First technique of CA tool is it comes from CA tools package, and the command that is used is sample.split to split the data. Run library, I mean make this package active. Then before before I run this command, I pass this set seed 101. If you also pass that 101, you will also come up with the same sample that I have come up. Or if you choose a different number, it will come up with a different random sample. Okay, I'm activating ggplot2 just because it is having my diamond data set. Otherwise, I don't need ggplot for cross validation. So diamond data set, we all are aware of. It has 53,940 observations across 10 variables, right? After this, I will pass this set seed 101, and then I do cross validation with the command sample.split. I mention the dependent variable price, and I mention the split ratio. Split ratio. Random. That's a random number, Weber. That is what I said. Okay, let me put it here. 101 is a random number. Now, If you now this 101 I've just randomly put, right? You will also put it randomly, but next time, see, as I said, first time it will pick the sample randomly, but next time, suppose tomorrow, Vaibhav, you come again and you want to just see, okay, which data I build the model, right? And suppose you have not run set seed, this is going to this line number 51 and 52 will randomly pick the data, sample, na? And random, when I say randomness, it will the random sample it picked today, will it pick the same random sample tomorrow? No, unless and until I I run this. This will fix my randomness. Okay, any number you can put even 1000 or this also, right? Any number, but whatever number you pick, your random sample gets fixed with this number. Clear, Vaibhav? Okay, quickly run 51 and let's see, should we pick at least some percentage of given observations? Yeah, we are picking now 75%, 75%. So test and okay, 101. Should we pick at least some percentage of given of no. Any random. No. See, you don't know what is the mechanism to pick that randomness at the back end, but it is picking. So it could be that every now I have 50,000 observation. It could be that it is picking every 100 first observation. I don't know. It could be doing systematic, but I don't know that. Okay, what is it doing at the back end? I don't know. It could be 1,000, it could be 10,000, or you can pick any random number. Just pick any random number. But if you want to match the data, match the sample and match the test and train with my data, then you pick the same number. Total observations to be considered is not mandatory. No, it's not. See, this number does not depend on the observations or the observations in my data. Okay, this number is not dependent. You can pick any random number. It's 0.75, Ram. It's 0.75. Okay. Now, see what it has done. When I run this line number 54, 53 sample, what it has done, it has created two subsets, split ratio. It has split the diamond dataset into two parts, test and train, or train and test 75 to 25. So it has divided, it has marked them as true and false. True is train data, false is test data, right? True will be having this 75% and false will be having the remaining 25%. Clear? Right? Now I am just running 58 in which I say create a subset of from diamond where sample I have where sample is equal to true, capital S. Vikash is it's capital S, right? Capital S in the split ratio. Check. I think you have put a small s. Just check. Okay. See, whenever you say na it's giving error, you just give me the error also. It will be easy. But yeah, here I was able to easily pick it up. Right? Okay. How many of you were able? Who is this web of error? Yeah, fine. Sample split. Could not find the function sample split. Okay. You see, now you got it. Now you have made two errors here. One, you have to, I think this is capital S. Check. Let me check. Yeah, it's capital S. Right? Second, Weber. Second, what you have done is, it is saying it is not able to find the function sample dot split. See, I told you sample split. Okay, let me sample dot split. Can you see which package is it coming from? Webhub. Webhub, you're typing privately in the private chat window. Please put it in the public chat window, right? Okay, which package is it coming from? Webhub will tell. It's okay, don't be sorry. No, I'm not saying, yeah, CA tools, right? So it is saying, see, I'm making you learn how to read the errors also, na? It say could not find function sample dot split. So what could have been done? What could have been missing? nahi, install, you have installed, I don't know if you have installed it not, you have not installed it, but you have not activated it at least. Even if you have installed it, no, that's, even you have run line number 38, you have not activated it. If you have not run library CA tools, even then you get the same message. Okay, got it? So what you have to do is just check whether you have run library dot CA tools. Okay, others, are you getting? How many of you have divided into test and train? Type T. Type T if you have divided into test and train. Okay, good. We'll wait for more confirmations. Wrap up, quickly do it. Right? So, got it? This is the first way you can divide it into test and train. Okay? I can check the structure. Okay. Can take random observation for train data separate and test data separately instead of splitting the random observations from. How will you pick up random observations, Lakshmi, if you have, and you split it also manually? If your data is a million, yeah, you can take. Of course, you can take. This is what, but you are not going to do that manually, na? Right? This is what a single code or just a two-liner code will help you do. Okay, right? But yeah, it's equivalent to if you pick them randomly. Of course, that randomness is not going to remain same, just the way you have fixed it by running set.seed. Okay, but yeah, you can do it randomly. Okay, now just forget this. Second thing, another package which can help you do set, set seed. We have done sample. This is another, not package, it's another command. I think you can. So I want you to first download Gapminder package, activate it, and okay, download these three. Let me share these: Carrot, Lattice, and Gapminder. Now, Lattice is a package required to run Carrot, so that's why we're downloading it. Okay, then activate them, and let's get Gapminder data. This is some inbuilt data again, Gapminder data. If you want to know more about Gapminder, it's a data on life expectancy, right? GDP and population by country. years another way you can do this cross validation is, see again this time I have just picked up 12, set.c 12, any random number I can take. Okay, yes, Caret we did. Angela, we did install Caret. Okay, no problem, you can install it. I'm waiting, not an issue. Now, if I see this function rep, what is this rep function doing? Rep replicates the value in X. It's a generic function and the default method is described here, right? Now, what is this rep doing? It is replicating the value 0 for 0.75% of the data. Okay? 0.75 into rows, in rows. Link Gapminder. Sorry, I could not. Send me link Gapminder. Excel means Rohit. Excel. Okay, that Excel. Hmm. I did not open any Excel. Is it? Wait. Okay, it's. Is it there? No. You can download it also. This one. This one. Let's view. It's view. N row. Remember we had done N rows. N row means count the number of rows. Counting the number of rows. Of that 75% it will replicate with 0. Of this 25% it will replicate with 1. Okay? And create two samples. It will create this sample command. It will see. Now when I run this gap m, this is the output I am getting. Right? 0, 1, 0, 1, 0, 1. So it has divided it into 75 and 25. Okay, and when I create a table, notice another way you can do. Okay, it has created a table. I am just creating a table just to let you know that, just to check how many zeros and how many ones has it created. And then as earlier, as we did earlier also, I create train and test line number 106 and 108. Okay, once you have created, now Rohit, you are going to tell me what exactly is the issue. Nobody will tell. Rohit will tell what exactly is the issue. He has sent me the error. Instead of forwarding it to me, Rohit, now you just think and tell me what is the error. Why do you think it's not working? I can't able to download Excel. Will I will help you download it later. For now, please concentrate on what we are doing, right? Why do you want to download it right now? We are not doing anything with the downloaded data set, na? I am saying, tell me what is the error. Why? What is the error you have? Why is there a error? Only Rohit will tell. Nobody will tell. Yes, Rohit. I'm waiting for your response. I don't know why you are after that download. You can do it later, but tell me what is the error. You did not get it now? Gapminder dataset, Rohit. It's an inbuilt dataset. It's an inbuilt dataset. It came from this Gapminder package. Did you download this package? It came from this package. I have not uploaded it. Okay. That is what I'm saying. It's an inbuilt dataset. But yeah, you can definitely download it. We have done that right Excel package. We have done right Excel package. With that, you can download this package also. Okay, or this data set also. Please, what is the relevance of the number in front of set seed? Okay, Angela, I'll explain that number. That this is just a random number to fix that randomness of picking the of creating the random samples. To this with this number, Angela, set seed, I can put it to any number, right? Any random number, any random number. Okay, let me see if, yeah. So if I put it to 12, right? This these lines, these codes are going to create some two samples, one representing by with zero, other with one. Yes, Angela. Yeah, could be. It could. It is picking. Let's say It's not picking every 12th, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, it's not picking every 12. You can assume it that it's picking every 12th element as um, maybe a test or a train. Angela, I'll explain it again. This number is going to fix my randomness. See, Angela, if suppose you don't run this set seed. Now understand, Angela, are you listening? Are you there? Okay. Now I am creating from a sample. I'm splitting the sample into two parts, test and train. Right? Right? And it is done randomly. Okay. So today you run this command, you run this, you split it, and you create your model on train data, right? Tomorrow you want to revisit that, right? Again you will run this. When you will run this test and train, will that be the same test and train, Angela, that you got today? No, right? It will again pick some random numbers and divide it into test and train, right? It will again pick some random samples and divide it into test and train. But tomorrow or maybe couple of days after, when you would want that, I want to see on which data I have built the model, so that if I want to do some tweaks, I can precisely do those tweaks, right? So I would want that tomorrow or anytime in future when I come, I should be able to pick that same random sample which I picked today, right? I should be able to do that same split, right? Are you getting it? So this random set seed will fix my randomness. Understand this word, fix my randomness. Okay? The randomness that, okay, again I am taking you to just a second. First time it will select a random sample. Today it will pick a sample randomly. But next time it will keep the randomness constant. It's going to pick that same randomness. But again, this you just put it to any random number. You just put any random number with set seed. It will pick the randomness accordingly. Okay? Fix the randomness accordingly. Clear? Randomness means it will, yeah, you're right, Bharat. It could be that way, but I'm not saying we are not focusing on the systematic way it is picking the data. It could be that every 12th it is picking, right? It could be that way, but I am not assuring you that. It could be every 24th it is picking. For 12, it is picking every 24th, right? But we are not testing that. Okay? Clear? Have you created this test and train for Gapminder? How many of you have created test and train for Gapminder? Sachin, line number 22 is not there in my script. Sachin, I will share. I have made some changes. I will share this file, this R script again. Okay, today. There are some changes I have made, so you just don't refer to that earlier one. Okay. Can I proceed? Right? Okay, I'll wait. Cap GAPM is a variable I have created. I have just named this as GAPM. Okay, Gayatri? Okay. So I am saying what is 12 here? Number of observations we are taking now? No, 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 no. It's just a random number. I am associating. I am associating a random sample with a number. 12 is not the number of observations. See, the number of observations are different. My total observations in Gapminder were some 1700. See, 1704. Sample number, you can take it as random sample number, but it could be any number. Yes, that is what I'm saying. Lakshmi, are you getting it? You can, okay. If I've created this, see, with random, with set seed to 1 2, I got 1 2 7 8 and 426, right? Let me see. I put it 1 2 3 randomly, and I again created these data sets. Let's see what I get this time. 1 to 7 8 and 4 to 6. But these numbers, this this I'm getting because of 75 and 25 ratio, but these 1 to 7 8 are not going to be these same numbers. They are going to be some different observations. Lakshmi, are you getting it? These are going to, because I've changed the set seed, they are going to be some different ones. Let me show you this also. Okay, see. Now, if you see this table, this 0 and 1, right? It's coming from 1 and 2. 1 2 sets, when I set seeds as 12. Now let's see if I check now. 1 2 3 4 5 6 7 8 is 1, and there 1 2 3 4 5 6 7th was 1, then ninth was 1, here 8th was 1, then some logic it has applied, but it has created a different uh, training and test data set. Okay, the number fixes the type of randomness. Yes, right, Arush. It fixed the randomness. Okay, quickly now. Invalid times. Because I'm looking at it. What is it message it is saying? Error, invalid. What is the error? It is error is this. Okay, in rep Gapminder, invalid times argument. Invalid times argument. Let me just see. I have picked up your code because, but it's running. It's running. So code is correct. I did not find anything error in this. No invalid times argument. Not sure. Yeah, your code is correct. I just picked up your code and run it. It was giving me the result. Um, I have never seen this error. Yeah, yeah. Don't worry. Well, I'll just check. Right. I'll just check invalid times argument. Right. So everyone is done. Right. Okay, there is another technique, create data partition, which it's not working. Maybe this package is outdated or something like that. So you can just ignore this third one. We are ignoring it, right? So there are two ways for now, right? There are other packages also which help you in test and train, creating test and train. We'll see, right? Now what we'll do is quickly, I want you to start with our first model. First algorithm we are going to learn is a very interesting algorithm, association rules, right? We'll cover the theory and then we'll take a break. Okay, Arush, how this is? Arush, it is creating a train data where in GAPM it is picking all the observations with 0 and it is picking all the observations where you have 1. Okay, it is creating two data sets, train where you have GAPM equal to 0. See, if you remember, if you see, This is my GAPM, right? If I yeah, if I check ask for GAPM, this is 0101 is my GAPM. It has created a, see, it's a vector. Can you see? So it has, sorry, it's a sample it has created with which has 0 and 1. So all the samples, all the observations with 0, it created, it put them into train data. Others, it put them into test data. Okay? See, clear? And notice what I'm saying here. Gapminder, from Gapminder, do you remember what is this box used for? It is saying wherever you have this position where GAPM is 0, put all those position, pick up all those position from Gapminder and put it in train data. Pick up all the positions where GAPM is 1 and notice why there after comma there is nothing. It means all the variables. Remember, all the variables. If I don't put anything after comma, it means all the variables, right? All the variables it is picking up and putting it in test. Got it? Okay. Now let's start with association rules. A very interesting algorithm. First, let's see what is association rules. And before we see what is association rules, let's understand, let's hear about this very interesting case. This actually happened at Walmart. Have you heard of this bear diaper syndrome? Any of you? No one? No one has heard of this bear diaper story? No one? Then you would find it really interesting, right? A very interesting combination of products, right? Beer and diaper. So this actually happened somewhere in I think early 2000, right? At Walmart, right? And a very interesting story, and you'll be amazed how big data can really come and uh, add value to business, right? The most famous is beer diaper. You can Google it around and you'll find more detail on it, but I've just put a brief explanation. Walmart discovered that through data mining that the sales of diaper and beer were correlated on Friday nights. Now what happened? On Friday night, Walmart, when they were observing their historical data, they observed that on Friday, beer sales shoot shoot up. That was very logical because it's a weekend coming. So whenever working parents or working fathers, they come from office, they used to pick cans of beer, right? Crates of beer rather, right? Okay. But they also found that diaper sales were also increasing, right? So of course initially they did not find any correlation between them, right? It determined it determined that the correlation was based on working men. Now, when they dig deeper into it, right? Dig deeper into each transaction and they tried to find, maybe they did some research, market research. Okay, someone who is picking up beer, is he picking diaper also? Then they found that it was determined that the correlation was based on working men who had been asked to pick up diapers on their way back home for work from work. So of course it was a weekend. I mean the weekend is coming, so everyone is in a weekend mood, right? And so the mothers, they wanted that the father should get the diaper so that they are also free of the child for some time. They can keep the child and they can enjoy the party, something like that, right? So this was a very, I mean, logically, if you think logically, do you will you find this, will you be able to find this relation? Unless until you have a data backing it up, no one will be able to logically link these two. But this actually happened, and when Walmart discovered this, right, it was able to increase the sales of these two products exponentially by keeping these two products nearby in their stores, right? So what they've observed on Friday is the men figured that they deserve a six pack of beer for their trouble, hence the connection between beer and diapers. By moving these two items closer in their store, Walmart reported the of both sales of both the items increased geometrically, right? So it really boosted just figuring it out what products the customers are trying to buy together, right? And this is just one example. You can find many more such examples. So, and this, it is not that this is a general pattern that all across all across US or all across their Walmart stores, this is going to happen. But in maybe a particular locality, right? So in that particular locality, Walmart was able to increase the sales of these two products exponentially by keeping these two products nearby, especially in those areas where this phenomena or this correlation was observed. Is that okay? So a very interesting. This I've just briefed it, but yeah, you can maybe if you want to read the entire story, you can read it on web. So that's called beer diaper syndrome and a very famous story when it comes to association rules. Now I will start association rules on this note that on this beer diaper syndrome, right? So you saw what can really date understanding the data do, right? Now, what are association rules? Association rules mining is an algorithm that finds interesting associations and relationship among the large set of data items bought together. Now, what this rule does is when you go to a store, you buy something, you create a bill, right? And it is bill is recorded, and in that bill you have all the items that you bought. Nisha went to the store. She bought item X, Y, Z. Then Rohit went. He bought item X, Z, A. Right? Then Bharat went. He bought some other set of items. Now this data is not, I mean, left in just a kind of a dump. Historically, millions of such transactions are created, right? And they are captured, and then comes association rules, which tries to find the correlation in the historical data, a million transactions, maybe over a year or 2 year, and tries to find the patterns in the purchasing habits or the purchasing patterns, right? In the purchasing habits, this rule, this algorithm tries to find which are the products customer is trying to buy together. For example, in this also you can see customer one, he is trying to buy, he bought, historically he bought these three products. Customer two bought these, customer three again bought these, and customer four these, right? Got it? This is called market basket analysis. I'm not sure if you would have heard of it. This is also called market basket analysis, a very famous term for given to this association rules also. The rule shows how frequently an item set occurs in a transaction. Means it could be even a single item or it could be an item set occurring in a transaction. The application of association rules mining are found in marketing, market basket analysis, in retailing, clustering, and classification. So you'll see this rule being applied in marketing, market basket analysis, for retail, clustering, and classification. Also, we use this rule. We use this algorithm. In market basket analysis, which is key technique used by large retailers like Amazon, Flipkart, Sainsbury, etc., to analyze customer buying habits by finding associations between the different items that customers place in their shopping baskets. Now, it is not that this is used only by retailers, but e-commerce players. Amazon, when you go to Amazon, you get the recommendations. Whenever you pick up any item and you put it in the basket, right, in the cart, you start getting recommendations. Yes or no? Again, you can now see what's happening at the back end. Recommendation engine. It's built on this particular algorithm. Okay. So analyze customer buying habits by finding associations between the different items that customer places in their shopping basket. The discovery of these association can help the retailer develop marketing strategies by gaining insights into which item are frequently purchased together by the customer. So when you get to know that bread and butter are bought together in a particular area, bread and butter are bought together on a retail store, what will you do? You would try to keep them nearby so that the customer do not have to try and find the other item, right? Getting it? We have one project in Simply Learn Simon. Okay, yeah, maybe yes. If you have, then a very interesting project, right? Okay, now got it. But on a e-commerce portal, it starts pushing you recommendation. So both ways, right? Okay, clear. Now this is the rule. It is the algorithm behind you may also like, right? You get this, you may also like this, you get these recommendations on Amazon and other websites as well, right? So this is the algorithm behind it. He is the main culprit of being you pushed to buy another product when you buy only one. Yes, over shopping, correct, right? So this algorithm is the culprit. Okay. So a priori algorithm is given by this was given by two Indians, R. Agarwal and R. Shrikant in '94 for finding frequent item sets in data set for Boolean association rules. Name of the algorithm a priori because it uses prior knowledge, so that is why it was named a priori, right? It builds on associations and correlation between the items. It is the algorithm behind you may also like, where you commonly see recommendations in uh, uh, where you commonly saw in recommendation platforms. Okay, it tries to answer below questions. How can you find frequent item sets in a data set? And it need not be a single item or two items. It can be an item set also, right? How can you find frequent item set in a data set? How can you find frequent items in the data set efficiently? It tries to answer these two questions. Okay, clear? Now, this association rules, I'll just quickly run through these definitions and then we'll go for a break. Okay. Now, this association rules, there are three terms you have to learn: support, confidence, and lift. Based on these three terms, you are able to get the best out of this algorithm. Okay. First one is support. You are able to probably pick the item sets, right? Or pick the right set of products that are bought together. Okay. First rule, support. What is support? Support gives you the frequency of occurrence of an item or item set in the transaction. So support of A is equal to transactions for A divided by total number of transactions. Clear? It gives you the proportion, it gives you the frequency of occurrence. It is the default popularity of the item or item set. Is it? Are you getting it? So if I get the proportion of A as 10% and the proportion of product B as 20%, so which is more popular? B, right? So it gives you the default popularity. A is a product, random product. Bharat, support of A. Here A is just a random product, name of a product. Okay. Okay, it gives you the default popularity. In mathematic terms, the support of item X is nothing but the ratio of transactions involving X to the total number of transactions. Okay, it is not only transactions where only A is bought. It is the number of transactions which include. It is the number of transactions or the bill or the orders where A was there. A single order can have multiple items, right? Right? Okay. when you place an order, when you do billing at the counter, you might be buying 10 items. If that includes A, it will pick up that transaction. As simple as that, right? Default priority, ratio of transactions involving X to the total. Clear? Support is clear to all of you? Next, confidence. Any doubt regarding support? Let me know, else we'll proceed. Confidence. Okay, no doubt, I think, right? Okay, confidence measures how likely an item Y is purchased when item X is purchased. Now, confidence tries to total customers. No, total popularity of X or total popularity of A, not customer. Popularity of product. Lakshmi, right? Okay. Now, what does confidence do? Now, this confidence tries to map. Wait. Let me explain. Confidence tries to measure how likely an item X is going to be bought when item, sorry, how likely an item Y is purchased when item X is purchased. This is what it tries to see. Okay. So how does confidence, how do we calculate confidence? And it is expressed as X to Y, like bread and butter. Yeah, you said, as Nisha said, bread and butter. How likely I'm going to buy butter when I'm going to buy bread, right? So how do I calculate that? Transactions involving both X and Y. Confidence of X, product X and Y is equal to transactions involving both X and Y divided by transactions involving only X. Now here I have a product X, right? So I am trying to find how likely a person who is buying X, how likely he is going to buy Y. Confidence of how much confident I am that a person who has picked up X is going to pick up Y. Are you getting it? Right? Okay. Likelihood, it measures the likelihood that a customer will buy X and Y together. Okay. Confidence. Clear? Confidence is clear. I'm going to just do the last and then we'll go for a break. Yeah. Yeah. I know. Just this last slide and then we'll go for a break. Okay, we'll do the examples later. Okay, lift. Lift is the factor by which the co-occurrence of X and Y exceeds the expected probability of X and Y co-occurring together had they been independent. Means how much, if whether when X and Y are bought together, right? What is the factor by which their sales increases had they been bought separately? Are you getting it? Right? So lift of X and Y is calculated by confidence of X and Y divided by support of Y. Okay? I pick up the support of Y, I put the support of Y at the bottom, at the denominator, and confidence of X and Y in the numerator. That will give me lift. Higher the lift, higher are the chances that X and Y are co-occurring together. Yes, it means the more is the lift, it means the better this chances of picking them up together, and more are these two items boosting my sales. Okay, clear? Ratio of lift to confidence is to support. Lift is the ratio of confidence to support. Where lift is less than 1, X and Y are negatively correlated. Where lift is greater than 1 means X and Y are positively correlated. Means they are positively correlated means there are high chances when X is picked, like bread and butter. They look like positively correlated. Bread is or butter is taken with bread a lot, right? And lift equal to 1, X and Y are not correlated. Clear? So let's quickly go for a break here. I know it was slightly lengthy, but we had to do this. Okay. And so I'm just putting up a time. I'll put up a timer for 20 minutes. Don't worry. We'll take a break for 20 minutes. Okay. And I am opening the poll. Please do participate in the poll. Request you to all of you to please participate and let us know how did you do in terms of patient delivery. The poll is open now, and I will see you on the other side of the break. Hopefully, you are enjoying the session, and thank you so much, everyone, for your participation. Okay, so I am just opening. I'm putting a timer for 20 minutes. Don't worry, we have time. So in case we are left with one algorithm factor today, we will cover that next week. But tomorrow, I am going to cover only regression. 3 hours, no other topic will be touched. It will only be regression. Regression requires 3 hours. In fact, sometimes more than that. So we are not touching any other topic except for regression tomorrow. Okay, is that clear? I hope that clarifies tomorrow's agenda. I'll do that, Arush, right? Don't worry, I'll do that, right? But later, right? Towards the end. So this is the timer. Please do come back as per the timer. I will see you on the other side of the break. Thank you so much, everyone. And I'm putting up, yeah, I'm going on mute now. Okay, hello everyone, welcome back. Please give me a confirmation if I'm audible. Harush, are you there? Okay, Arush is still not there. No worries. Okay, got it, Suman. Okay, Arush got it. Okay, thank you so much for the confirmation, Arush, and thank you, Suman, for helping Arush. Okay, can we proceed? Right. So we have seen lift, confidence, and support. Right, support, confidence, and lift. Right. So let's see these with the help of an example. Given the set of transactions, find rules that predict the occurrence of an item based on the occurrence of other items. So these are 8 transactions: apple, beer, cereal, and chicken. Right? Then these are how the transactions were, 8 transactions happened. So to calculate the support of apple, what will be the support of apple? Total number of transactions of apple, which is how many transactions of apple are there? 4. And how many total transactions? So what is the support of apple? Zero point 0.5, right? Confidence of apple to bear means how confident I am when a customer will pick apple, that he will also pick beer. So I'm going to find the support of apple and beer together. How many transactions are there for apple and beer? What is Vaibhav? Who does that means? 3 transactions. 3 upon 8 is the support of apple and beer, right? And support of apple is 4 by 8. Who picks up apple with beer? Customer will pick up. These are the historical transactions, na? Okay, okay, got it. Don't write ऐसे ही ना. It creates confusion. I thought maybe you did not understand, right? Okay, fine. Okay, got it. Confidence, I'll repeat. Confidence of apple to beer. What is the support of apple to beer? 3 by 8, right? Means 3 transactions having apple and beer upon total transactions, right? And support of apple is, of course, 4 transactions, right? 4 by 8. So confidence of apple to beer is 75%, right? Everyone agrees? Is that clear to all of you? Now let's see lift. Lift of apple to beer means how likely, how much likely that that someone will pick apple and beer. Had they picked them separately, how much more likely they are going to pick them together, right? So support of apple to beer is going to be support of apple to beer, which is 3 upon 8, right? Divided by support of apple and support of beer. Okay? Or what you can do is you can club this and call it confidence of apple to beer, right? It's the same thing. Yes, right? So 0.75 upon 0.8, so it will be 1 only. I think this is, oh sorry, 3 by 4. and yeah, this is also 3 by 4, right? 1. So it means people, those who are picking apple and beer separately, and when they pick them together, as such, apple to beer, picking apple and beer, more or less you can say they are not correlated. They are not boosting the sales. If they are picked together, they are not boosting my sales. Clear? Okay. Next example. Let's say there are total of 100 customers, 20 bought milk, 16 bought beer, and 12 bought both. Okay. So 12 bought both. 16 bought butter. Yes. Vaibhav, it's but oh, did I say beer? My bad. Right, right. My bad. Sorry about that. So 16 bought butter, and I'm into that beer mode, right? 12 bought both. Okay. So it's a weekend coming now. That's why. Okay. Okay. So yeah, coming back. 20 bought milk, 16 bought butter, and 12 bought both. So support of milk to butter. Now support of milk to butter means how many, what are the total proportion of transactions wherein milk and butter are bought together, right? 12 by 100, very clearly, right? Confidence of milk to butter is equal to, confidence of milk to butter is equal to support of milk to butter upon total transactions of milk, right? Confidence, support of milk to butter, which is 0.12 upon total transactions of milk, 20 upon 100. So it comes to be zero point 0.6. Clear? Confidence is clear. Last, lift. Let's see lift this time. Milk to butter, lift of milk to butter. Confidence of milk to butter upon support of, yes, confidence of milk to butter upon uh, confidence of milk to butter is zero point 0.6. Support of butter, right? So what is the support of butter? It's 0.16, right? So why have I mentioned 0.1, 0.08? Okay, this, yeah, this is, I think, oh yeah, this is wrong, right? So can you calculate lift now? I want you to calculate the correct lift. I think this is wrong. Can you calculate the lift and tell me? It is confidence of milk to butter upon, yeah, so correct. So confidence of milk to butter is zero point 0.6 and support of only butter, right? So it's support of butter, na? Wait. It's lift of milk and butter together you have to find, right? So what is the answer? Who will tell me? 6? Yeah, it's divided by 0.1. So that's what I was wondering. Yeah, 3.7. It's half of this, right? I think the only, yeah, I have I don't know why these numbers are wrong. I'll correct it and share the correct slide. Okay, don't worry. I'll correct it and share the correct slide. Okay. So it's 3.75, right? It means when they are bought together, higher the lift, more are they correlated. Okay, means they are more likely to bought together than independently, right? Than their independent transactions, they are more likely that they will be bought together. Okay. Last example. Quickly, we'll run through this and then we'll go to. I've joined initially some of the group, but I missed the series. Also have mistakes. Yes, told there are mistakes. Which PPT? This particular PPT are you talking about? Okay, in general. Yeah, yeah. No, these are not simply learns, right? I have because these to explain these concepts I have created some, but I'll correct this. Don't worry. Okay. Okay, fine. Can we start with this quickly? I want you to run through this. I want all of you to read through support quickly. See what is support. Is it correct? Also, just check it is correct also, and how is it calculated? Support of milk, diaper, and beer. One, two, milk, diaper, and beer. Three. So two transactions, right? Milk, diaper, and beer are two transactions upon five. Correct? Confidence of milk, diaper, and beer. So when we say milk, diaper, and beer, I'm saying here milk and diaper is my item set. Okay, so it should be milk, diaper, and arrow. So it will be milk, diaper, something like this. Milk, diaper, to beer. Okay, so it should be like this. So milk, diaper is a item set. So milk confidence of milk, diaper, and beer is equal to the total support of milk, diaper, beer divided by number of transactions of milk and diaper. Okay, support is 2 by 5 and total number of transactions of milk and diaper together 1, 2, and 3. So 2 by 3. Confidence is 0.67. Is it clear? Milk and diaper is a item set. I'll correct this as well, right? So don't worry, I'll correct this and share it tomorrow. Can I proceed? Lift. Did you check the lift? Did you check how do you calculate lift? Is it correct? Did you get it? Okay. So 0.67 upon zero point 0.6, right? Yeah, of course, 0.67 is the confidence of milk diaper divided by support of beer. Support of beer is 1, 2, 3. 3 by 5, which is zero point 0.6, right? So 0.67 upon zero point 0.6, which comes to be 1.11, right? Clear? How do you calculate these? Okay. Now let's go to R and let's start with association rules. How do you? First, I want you to install this package A rules and run it. I'm sharing the code. Codes, install it and make it active. Now, once you do it, there is this, see how the transactions are recorded. This is your, these are your transactions. Notice this is how the data should look like in terms of transactions when you are historically analyzing the transactions, right? So if it is not in this shape, you have to make it look like this. You have to put it in this shape, right? What is each row? Each row is indicating a single transaction, and in a separate column you have the products that are bought in that transaction. Okay, so first transaction, citrus foods, semi-finished bread, margarine, ready soups. Second transaction, tropical fruit, yogurt, coffee. Third transaction, only whole milk, and so on. So there are 9, 8, 3, 5 transactions. Clear? Right? So how the, when you run a priori algorithm, this is how your data is fed. Clear? So whenever, if you are analyzing historical data for a store or for an online e-commerce portal, right? For a priori, you have to get and feed the data in this format. No, no, in single row, sorry. Okay, leave it. Fine. Okay, so a priori, all of you have downloaded and activated. A priori type A, if you have done, if you have installed and activated a priori. Okay, next. Now once you have installed a priori and downloaded it, next. No need to set the directory, leave it. Run line number 70 and okay, now read dot transaction. Remember earlier we used to do read dot CSV, read dot table, read dot Excel, right? We have done that, read underscore Excel. But here, a priori algorithm, A rules, right? It reads transactions. It reads the data transaction wise. That is why we have this command called read dot transaction. Okay, and I can use this line number 17. Okay, now how does read dot transaction differ from CSV? Read dot CSV. Read dot transaction, you use the data in a, is used as the data is in transaction format. It reads the data row wise. CSV, read dot CSV reads the data column wise. Is that clear? So this reads the data row wise and it knows that these are transactions are fed into this algorithm. Okay. So you can run straight away, forget everything and run line number 17. When I run this, oh, I did not activate the package. Read dot transaction. When I do this, I get this window. I can straight away pick the file. Oh, did I? I think I have not shared this. I have not shared it, right? Oh, then you should have told me. Just slipped from my mind. So sorry about it. My bad. My bad. I'll. But for that PPT, I will correct it and replace it. Okay. So don't just take the data set right now. For the details, right? For that content association rules, I'll correct that and replace it today. Okay. Now you can take this data set from session 6. Thank you, Sachin, for reminding us. Sachin said the first one, right? All of this, all of you are enjoying the music, right? We were enjoying. All of you were enjoying the music. I was speaking, and you were enjoying. Okay, now I want you to pick up the file using line number 17 only. 17. After you after you activate a rules using library, you will be able to directly run line number 17. And you have to pick up this association rules a priori algorithm file, Excel. Okay, pick this Excel, open. When you do this, what happened? Some issue with the file. Okay, name it as groceries item. I did not name it. Okay, in 17, I did not name it, right? Please name it as, I'll just pick the same name. Groceries underscore item. I did not name it. That is why. Okay, name it as groceries underscore. Okay, now have you done? Line number 17 is done. Then line number 26. Once you're done with line number 17, inspect. Inspect will give you the details of the transactions. First transaction, second transaction, right? And so on. Wait. There is some fine. After that, line number 29, size. It will give you the number of products that are there in each transaction, right? Size. Line number 29. When you're done till 29, just type 29. Okay. Now Okay, no, I want all of you to confirm those who are done till 29. Once you're done, I'll wait. No problem, I'll wait. But when you're done till 29, just type 29 in the chat window. 29 is inspecting. It is giving you, just run it. Arush, see what is the output you're getting. All the data, all the products that you bought in the transactions. It has, right? Inspecting. Okay? Sorry, 29, my bad. Oh, I was explaining earlier. 29 you said, right? 29 is giving you the size. Each count of the products gives you the count of items bought. Okay? Count of items bought in each transaction. Arush, clear? Okay? Then, a priori algorithm. Now we are going to apply the a priori algorithm. Algorithm used to create support, confidence, and lift. Okay, now when I write the a priori algorithm, I mention the data set, and see, if I don't mention the parameters, now what are these parameters? I am mentioning the parameters wherein I am mentioning that minimum, give me the list of all the associations, right? All the associated products. If suppose I don't mention this parameter and I just run a priori algorithm, it is going to create all the infinite. There are going to be infinite relationship, right? Even if the slightest of the relationship is there, it will give me that. But I don't want that complete list. Na? What will be my interest area? Give me top 10, top 20, right? So what I mention here is I mention the parameters wherein I say give me transactions where support is at least 0.01. Means at least the product has 1%, a product is there in 1% of the transactions, right? Then only I can really tweak the, make some changes. If the product is not even there in 1% of the transactions, it's better not to analyze the product, right? It's like a, just a, you can say, not that important product, right? And similarly, I'm saying confidence. At least it should be zero point 0.5. If the confidence is not zero point 0.5, then don't give me that rule. Is that clear? Parameters. So it defines the minimum value of support and confidence. Do not select any item where the support and confidence is very low, and that is what it's saying, right? So we are not selecting any rule, or we are not picking any item set where the support and confidence is very low. Okay? When I run this, it gives me some output, right? Let's not look at this output for now. What you do is create a summary of new grok. That create a summary. Everyone is done till 44, so that I can move up. 44. Type 44 if you're done till 44. Okay. Then summary. Run the summary. It will give you the summary of the support, confidence, lift, right? Then I run this command called inspect new grok. Inspect new grok is what I really need. So I put this in view, and I get these 6 transactions. I get these 6 transactions wherein notice confidence, support, and lift. A refresh or you mean update, Angela? You have to close it. Just close it. Better is just restart it. It's better to restart, okay? Got it? Then, based on the lift, I have sorted them. Okay, done. Then I have just sorted it based on lift, and you can see when I have sorted it, if I view this, so support, confidence, and lift. So based on the lift, I'm going to see that this is a deadly combination. It has a very huge lift, and look at the count of transactions is also very high. Then bakery and life, canned and beer, right? So, okay, got it? So, I have another example. You can just maybe do it yourself later, right? So, let's now, what we are going to do is we are going to start with another interesting, very interesting algorithm called PCA, Principal Component Analysis. Everyone is done till line number 62, right? Okay, fine. So can we proceed to the next algorithm, 60 PCA, Principal Component Analysis, right? And factor analysis. We might not cover factor analysis today, but we'll do principal component analysis. Okay. Okay. Now, what is principal component analysis? To understand that, first let's understand supervised and unsupervised machine learning algorithms, right? So you would have heard of these two terms, supervised and unsupervised, right? In supervised learning model, input and output variables are given, and in unsupervised learning model, only input variable is given. Now understand this. uh, Let me take that example which I took there. Not this one. Where did I write that? Where was that Excel? Just give me a minute. Okay, this is the one. Yeah. I created an. Okay, let's understand supervised and unsupervised in a separate sheet. I'll just create a separate sheet. I had created an example. Okay, I think it did not get saved. Anyways, right? Supervised and unsupervised. Suppose I have y variable which is price, right? Based on x1, x2, x3, right? I have y variable which is the price of housing based on some three variables, population, let's say this is population, and some other variables, right? Now, when you collect data and you have a dependent variable, right? This is my dependent variable, price. I'm trying to predict price based on x1, x2, x3, right? And you have labeled independent variables, population, let's say um, male, female density, right? And some other third variable. I have labeled three variables. I have three labeled variables, and I also have a dependent variable, and this is a sample, right? Based on which I will be doing cross validation first, test and train, and then train on the base of training. I create a I will create a model which will try to predict the price, right? So this is called supervised learning because I have labeled variables. First of all, some name variables have name, and second, I have a dependent variable already, which is guiding me, supervising me, right? Dependent variable is already there because even in my training and testing data, I will have dependent variable, right? That is called supervised learning. Now, what happens in unsupervised? Only input data is given. Now in unsupervised, especially a very good example of unsupervised is clustering. What happens is in clustering, you will only have X variables and you will have to cluster these the data based on the features of x1, x2, x3. See clustering, understand. I will not have a variable, I will not have a dependent variable which will be already clustering it. Cluster 1, put this in cluster 2, right? Then cluster 1. This will not be there. It will, the algorithm, clustering algorithm will automatically start picking up samples and start clustering them based on the features. Clear? I will not have a dependent variable. Second, I might not even have the labels of the variables. Clear? Is that clear? That is what it is saying. In supervised, algorithms are trained using labeled data. In unsupervised, algorithms are used against data which is not labeled. Okay? Then algorithms or some of the supervised learning algorithms support vector machine, neural network, linear, logistic regression, random forest and classification trees. These are supervised. Even regression is there. Yeah. Unsupervised. Clustering algorithm, K means hierarchical means, PCA, which we are going to do now. PCA is also unsupervised, and then factor analysis is unsupervised, and also association rules. Notice in association rules, what we are trying to did we have any dependent and independent variable in association rules? Did we have and did we have any labels? Notice, not even labels, only transactions were there, right? So that is also unsupervised algorithm, right? Okay, supervised learning is a simpler method, unsupervised is a complicated. Now there are some more majorly these are differences. You can read through the remaining, right? So this is again, as I mentioned earlier, supervised algorithms, classification, regression, SVM, unsupervised. These are just samples. No, I mean not the exhaustive list. Okay. Okay. Now coming to principal component analysis, let's understand what is PCA. It's an unsupervised technique of machine learning. It is a dimensionality reduction technique. What do you mean by dimensionality reduction? It reduces the variables that are to be put in the final put in the model, right? It reduces those variables, reducing unwanted variables. Okay, no, it will not reduce the unwanted variables. I'll tell you. Just hold on, right? I will not say it will not reduce the unwanted variables because it creates new variables which are called components, principal components, right? It creates new variables. So that is why they are not named. We call them as principal components. Okay. So it principal component PCA is a method of obtaining important variables in the form of components. Right. Now how are these components uh, created? I'll explain, right? From a large set of variables available in the data set. Let's say I'll take an example. I'll open this regression PCA. Okay, here we go. PCA, right? Suppose, yeah, it reduces, definitely reduces the set of variables. But yeah, hold on, right? It creates new components. That is what I'm saying. So let's say you have created a model which is based on 10 dependent variables. Based on that, you are trying to predict the price. Okay, these are the 10 variables. Okay, named and 10 independent variables, right? But what I can do with principal component is I create only 3 principal components which are a linear combination of these 10 with some weights. Can you see? PCA1 could be A1 is a weight and X1 is a variable, right? I created PC1 which is a linear combination of this, and I created 3 principal components, and these 3 principal components are able to capture the 95% of the variance. Notice, first, when I created the first principal component, it captured 75% of the variance in the data. Understand? See, variance, capturing the variance means you are trying to predict when you're, what is variance? You all know what is variance, right? It is once you are able to capture the variance means you are able to predict, right? Capturing maximum variance means you are able to predict it more accurately, right? Right? Yeah, if you are able to capture exactly variance, but we are not God, right? So we will always have some errors, right? Okay. So with these 3 principal components created, I am still able to capture 95% of the variance. So do you think I would really want to go with a very complicated model? If I am able to capture 95% still, right, with just 3, creating 3 principal components, I would want to simplify my model, right? Right? I would want to simplify the model, right? So we try to model the variation in y based on the variation in x, model the change in y based on the change in x. Yeah, it's the same thing, right? So you getting it how principal components are created, right? Now let's quickly go through the concept. A principal component is a normalized linear combination of the original predictors in the data set. They are summary variables which are not correlated with each other. Now what happens is, why is there redundancy? Why do we create principal component? There are lot of variables, let's say like temperature and rainfall, or right, they would have some correlation among themselves, right? They would have some correlation among themselves. So when, and similarly there will be other variables who will be correlated, and when they are correlated means both of them are impacting y in a similar way, right? Correlation, when both are it means there is some redundancy in the model. Redundancy means both are impacting y in the same way, so I don't need both of them now. If suppose distance and let's say average wind speed and temperature, let's say these are perfectly correlated, do I need both of them? No, I would not need both of them. If they are perfectly correlated means they both are impacting y in the same way, right? I would not need both of them, right? population and density, right? I would not need both of them. So this principal component helps remove the redundancy. It will pick up only the weight that are needed. So within, if it is created, it is going to pick up a more weight for density and maybe, and then a very minor weight for population if needed. Getting it? Right? So principal components try to capture maximum variance within themselves, need not be all. PCA reduces the dimensionality. So these are the dimensions. So it reduces the dimensionality from 10 to 3 now, this model, right? And also the redundancy by combining original variables in a way that it captures maximum variance. Is that clear? So we are trying to capture maximum variance. In this, we are able to capture 95% of the variance of the model which we created earlier. So even then it is fine. Now I have been able to simplify the model. Now this is only 10. Sometimes in real life scenario, you might have 25, 50, 50 variables, right? So I will try to find the most relevant of them, and I will create principal component is going to create the most, pick the most relevant, pick up, give them weights, and create the principal components. Is that clear? Is that clear what it does? Right? Okay. PCA is a tool that has two main purpose: to find variability in the data set and to reduce the dimensions of the data set. Reducing dimension means that redundancy in the data is eliminated. Okay. This can make patterns in the data set more clear. Therefore, principal component analysis is a good tool to use if you suspect you have redundancy in the data set. Redundancy does not mean that the variables are identical. It means that there is a strong correlation between them. This is a very important sentence. Is that clear? Redundancy does not mean that the variables are identical or they are not required. Okay? It means there is a strong correlation between them. So we are able to reduce the redundancy using PCA. Principal component analysis reduces dimensions by projecting the whole data set onto a complete separate space. So it creates altogether some different dimensions, right? This is my data set. It creates some different dimension, and notice specifically these are orthogonal. Orthogonal means perpendicular, so that there is no correlation between this principal component 1 and principal component 2. Is that clear? There is no correlation. So it creates, and maybe it creates some other component in the 3D space, right? Right, which is completely not correlated. These principal components are not correlated. Okay. Okay. These components are extremely useful as uh, criterion variables or predictor variables, as criterion variables and predictor variables in later data analysis. Reducing the number of variables of the data naturally comes at an expense of accuracy, but the trick is to, or trick of dimensionality reduction is to trade a little bit of accuracy for simplicity. Getting it? So that's the guiding thought, that's the principal thought behind it, that we are going to trade a little bit of accuracy for simplicity. Because smaller data sets are easier to explore and visualize and make analyzing data much easier and faster for machine learning algorithms without extraneous variables to process. Is that clear? The concept of principal component. Now this is what it does. First variable captures 40% of my variance. Second principal component comes in, it captures another 18%. Third principal component comes in, it captures another. So I think with 4, I would be good enough because I will be capturing maximum of my variance. Right? Okay, now let's go to R and iris data. Iris data we have seen earlier, iris data. This is the data in base R. So you just activate, call this data and view it. This is a data of 3 species of iris flowers, Setosa, versicolor and virginica. 150 observations, 50 observations each. And if you run structure and summary, you will see 150 observations across 5 variables, right? Now understand that when principal component analysis is creating a linear combination of the actual or the original variables, do you think it can include categorical variables? Do you think categorical variables can be included? Can categorical variables be accommodated? No, right? So it can only, PCA can only work on numeric data, right? Now in this iris data, I have this fifth variable species, right, which is categorical. So I'm going to just remove that. In line number 14, I'm just removing the fifth one. And in 15, I'm just checking the head of. Now see, I have removed the fifth variable, so I'm left with only sepal length, sepal width, petal length, and petal width. After you do this, run line number 20. Princomp is the command which is going to do all the dirty work at the back end and create principal components for you. Princomp. Line number 20 and 22. When you run line number 22, summary of Princomp. Done. Summary. Now let's understand the summary. Notice what is summary importance of the component. It is giving you the importance of the component. See, of these four, I have only four: sepal length, sepal width, petal length, and petal width. I am able to capture, see, standard deviation captured by first principal component, or variance. You can write cumulative variance captured by first principal component is 72%. Sorry, proportion of variance. Yes, 72%, right. And then as second component comes in, how much variance I'm able to capture? Cumulative proportion, na? Cumulative proportion of variance. So I am able to capture with only two variables, I am able to capture 95% of the variance in the data. Means I am able to capture 95% of the accuracy, 95% of the efficiency or efficacy of the model, which would otherwise I do it with four variables. Okay, clear? Are you able to do this? Summary. So if I see PC, it gives me that same thing. How much standard deviation I'm able to capture? Four variables and 150 observation. It is just yeah. This is I have already explained. Plot. If I plot PC with a line, notice this is what, how much of the variance is it capturing? Principal component 1, 2, 3, and 4. Because princomp error as vector cannot closure to vector any type. Showing error because let me just take a look, right? Just give me 1 more minute. I'll just close this last and then I'll just take a look at yours, right? Attributes of PC, line number 31. It will just give you the names of the uh, whatever is the result of the standard deviation. Just give you the attributes of the output. I'll share it, Sachin. I'll share it. It's then PC loadings. Now, what are loadings? Loadings are the weight. Remember, to create the principal components, I have used some weight. I use some weight in the Excel, right? Loadings are the values. See, these loadings, component 1 is created with these weights: sepal length, petal length, petal width, and sepal width. Okay, so these are the loadings represent the correlation between the components and the original values. These are the values with which we form the equations of PC, principal component. Okay, since first two PCs are able to explain 95%, I have already done this. We need not include all variables. That is how we cut down on variables, right? So PC will give you the weights. So to create the principal components. Okay. No, our as such you are not able to see these. And when you put these, PC score is going to give you the values that that go into the model, right? So PC scores, PC dollar scores. It will give you all the replacement values of the four components, okay, with which those principal components are created. Okay. Now you get out of that mindset. You have to see the calculations. Okay. All you have to see is analyze the results. That is why we are doing learning coding, right, Lakshmi? If I have to, if yesterday ANOVA, when I could do ANOVA, and if I ask you, okay, now go into that backend calculation which we did in Excel, right? It was a very simple example. Now you can think if that example is having far more variables, right? So you should know that okay, this is what is happening at the backend. Okay, I got it, right? Okay, then that's it. Okay, you can create this plot, activate this library, sorry, install this package and activate GG45, and you can create this plot, iris plot based on the two components. How are the two components able to predict my three species? Okay, it tells you that principal component 1, principal component 2. So it is able to predict the three types of iris flowers. Okay, it just shows you that. Okay, so we'll stop here today. Yeah, Arush, princomp is just creating the principal components, right? It is just creating the principal components. I'll share it. I'll share the files. Okay. Scores is equal to true means I want these scores which I calculated, these scores, right? I want these scores, so I put scores is equal to true, and core, I think it's a correlation, right? Correlation I also put it true, and scores I also put it true. Okay. Variance of component 4 is low. Can we remove? Yeah, of course, we are not including the fourth one. We are just including the first two, Angela. Okay. We are not including the fourth one. So that's it for today. And we will continue with tomorrow. We'll do regression. Whole entire session is going to be on regression. It's a very important and a very comprehensive session. Okay. And then factor we'll do maybe Monday or Tuesday. Factor analysis. Okay. Yeah, I'll share the link and I'll update this also principal component file. Okay. Thank you so much, everyone. I'll see you tomorrow, same time. Till then, take care. Okay, goodbye.